Hello to my scholars, learning chemistry through videos. You know you love it. Alright, the mole. No, not like something on your face. Put the mirror away. It has to do with chemistry. Right, so let's read this. What's it say? Chemical particles are very small. We know they're so small you can't see with naked eye. Most microscopes aren't even good enough either. So counting them is difficult. Well, it makes sense. A scientist named Amadeo Avogadro, it's a guy from Spain, developed a new unit to help chemists count atoms and molecules. Okay, so a new unit, interesting. Instead of just counting 2, which so a pair, 3 is a trio, 12 is a dozen. Ooh, now I'm hungry. I want donuts. Or 144, which is a gross. That's a dozen, by the way. Atoms at once. Avogadro decided to count 6.02 times 10 to the 23rd atoms at once. He called this new group a mole. So a mole, so this is a mole. So a mole equals whatever that is, which in scientific notation is 6.02 times 10 to the 23rd. Well, I see why we don't want to write it out, right? So we use scientific notation. So scientific notation. Avogadro based his number on careful measurements of carbon-12. Ooh, carbon-12. I remember from one of our challenge problems, this is an isotope. It's just a specific mass of carbon, carbon-12. Alright, so anyway. 1 mole is the number of carbon atoms in 12 grams of carbon-12. Scientists still use this unit to count any type of particle. So for example, if you have a mole of H2O, that's 6.02 times 23 molecules. It's a molecule because H2O is a covalent compound, it's a molecule. 1 mole of calcium is 6.02 times 10 to the 23rd atoms of calcium. It's not bonded to anything, so it's just an atom. 1 mole of CO2, yeah, you guessed it, is 6.02 times 10 to the 23rd molecules of CO2. Again, molecule because this is a covalent compound. 1 mole of NaCl, well, it's not going to be a molecule. 6.02 times 10 to the 23rd ionic particles, NaCl. Alright, so I get the idea. Mole, 6.02, blah, blah, blah. Mole, 6.02 times 10 to the 23rd. Whew! Okay. So what good does that do me? Ooh, math! Alright, let's just say, if 24.08 times 10 to the 24th atoms of aluminum react, how many moles of aluminum is that? And then we've got this reaction, which I don't really understand. So I have the atoms, and I know I need a conversion factor. I know I need moles on top, atoms on bottom, because I'm going 2 moles, so moles goes on top. Oh, here we go. So 1 mole equals 6.02 times 10 to the 23rd atoms. So then this goes in, it gives us 4, and then we subtract the exponents, so that's just 10 to the first. So 4 times 10 is 40 moles of aluminum. Okay, how many molecules? So now it's asking for molecules. That's going the other way. Are found in 6 moles of chlorine. So we're starting with moles of chlorine. Moles on bottom, molecules on top. We put Avogadro's number, 6.02 times 10 to the 23rd. We get 36.12. You put it in scientific notation, right? Makes it 10 to the 24th molecules of Cl2. That's a lot of molecules. Okay, make some observations. Be ready to discuss them with the class. I look forward to seeing you. My night it's not the same when I don't see you. I know it's the same for you. But if we look at the moon at the same... Okay, bye-bye.